Hello and welcome to Math Zone African Motives. Today we're going to dive into a powerful method for solving systems of linear equations. We'll be using Cramer's rule. By the end of this tutorial, you will be able to set up and solve a 2x2 system of linear equations using this method. Let's look at the problem we'll be tackling today. Our objective is to solve for the variables p and q using Cramer's rule for the following given system of equations. Before we begin, notice that the second equation, 2p plus q, 4 equals 0, is not in the standard form we need. For Cramer's rule, our equations must be in the form x plus by equals c. So, our first step will be to rearrange this second equation. We need to move the constant term, the minus 4, to the right side of the equal sign. To do this, we add 4 to both sides of the equation. Excellent. Now both equations are in the correct standard form. Let's rewrite our system. Our system is now 3p minus 4q equals 5, and 2p plus q equals 4. With this setup, we are ready to apply Cramer's rule. Let's first establish the formulas we'll be using for Cramer's rule. This will set a clear roadmap for our solution. The rule provides a direct way to find the solution for each variable using a series of calculations. Here, D represents the determinant of the coefficient matrix, which we'll call the system determinant. D subscript p is the determinant where we've replaced the p column with the constant terms. And D subscript q is the determinant where we've replaced the q column with the constant terms. These three determinants are the key components of the rule. Calculating them correctly is essential to finding our solutions for p and q. Remember, the final step for solving for a variable is always to divide its specific determinant by the system determinant. Now, let's start by calculating our first determinant, D. We'll begin by calculating the determinant of the coefficient matrix, which is denoted as D. This is often called the main or system determinant. To do this, we'll extract the coefficients of the variables p and q from our system of equations. So, the determinant D is the determinant of the matrix with entries 3 or 4 in the first row and 2, 1 in the second row. Now, let's compute its value. For a 2x2 matrix, the determinant is calculated by multiplying the elements on the main diagonal and subtracting the product of the elements on the off diagonal. This means we calculate 3 times 1 and then subtract the product of 2 and negative 4. This is 3 minus negative 8. Simplifying gives us 3 plus 8, which equals 7. So, the system determinant D is 7. Next, we will calculate the determinant for our first variable, p. We denote this as D subscript p. To form the matrix for D subscript p, we take the original coefficient matrix and replace its first column, the column of p coefficients, with the column of constants from our equations. The constants are 5 and 4, so we replace the column containing 3 and 2 with the column 5 and 4. The q coefficients, 4 and 1, remain the same. So, our determinant D subscript p is the determinant of the matrix with entries 5, 4 in the first row and 4, 1 in the second row. Let's compute this determinant using the same method. We multiply the main diagonal 5 times 1 and subtract the product of the off diagonal 4 times 4. This gives us 5 minus negative 16, which simplifies to 5 plus 16, resulting in 21. Now let's calculate the determinant for our second variable, q. We denote this as D subscript q. To form the matrix for D subscript q, we take the original coefficient matrix and replace its second column, the column of q coefficients, with the column of constants. This time, we keep the p coefficients, 3 and 2, and replace the q coefficients, 4 and 1, with the constants 5 and 4. The result is a new 2x2 matrix. So, our determinant D subscript q is the determinant of the matrix with entries 3, 5 in the first row and 2, 4 in the second row. Again, let's compute its value. We multiply the main diagonal, 3 times 4, and subtract the product of the off diagonal 2 times 5. This gives us 12 minus 10, which equals 2. We've now successfully calculated all 3 necessary determinants. Let's recap their values. We found that the system determinant D is 11, the determinant D subscript p is 21, and the determinant D subscript q is 2. Now that we have all the pieces, we can plug them into our Cramer's rule formulas to solve for p and q. First, let's find p. The formula for p is the determinant D subscript p divided by the system determinant D. This gives us 21 divided by 11. The problem asks for answers rounded to 3 decimal places. So, we'll convert this fraction to a decimal. 21 divided by 11 is approximately 190909 repeating. Rounded to 3 decimal places, our value for p is 1909. This matches the result in the provided memo. Now, let's solve for q. The formula for q is the determinant d subscript q divided by d. This gives us 2 divided by 11. Converting this to a decimal and rounding to 3 places, we get approximately 0.182. This also matches the memo. So, the solution to our system of equations is p equals 1.99 and q equals 0.182. We have now seen, step by step, how to solve a system of linear equations using Cramer's rule. To be thorough, let's compare our answers with the memo. We found p equals approximately 1.909 and q equals approximately 0.182. The memo confirms that p is indeed 21 over 11, or 1.91, which is a slightly rounded version of our result. The memo also confirms that q is 2 over 11, or 0.182, which is identical to our rounded answer. Our calculated values match the memo's results, showing that our method and calculations were correct. Let's conclude our tutorial. Today, we've walked through solving a 2x2 system of linear equations using Cramer's rule. We started by rearranging our equations into the standard form. Then we calculated 3 essential determinants: the system determinant d and the determinants for our variables, dc and dq. Finally, we used the Cramer's rule formulas to solve for p and q, finding that p is approximately 1.909 and q is approximately 0.182. Thank you for watching this tutorial from Math Zone African Motives. If you found this video helpful, please subscribe for more tutorials like this one. We'll see you next time. Please subscribe for more tutorials from Math Zone African Motives.